Chapter 2, Section 4, Applications with Percent. The first part they're going to talk about is, or I'm going to talk about, is converting between percent notation and decimal notation and then solving percent problems. Well, I'll tell you right up front, probably everything you need to know about this section is that percent means hundreds. It means something over 100. So 70% means 70 hundredths. And if you understand that that word means hundredths, with a th behind the hundred, 90% of what you need to know is done. And that's exactly where they start here. Percent notation is just another word for something over 100. And we have worked with fractions. Hopefully you can get past any kind of fraction fears that you may have going on and really convert it to do that, because when we work with equations and stuff, we need to work with numbers in the multiplication so we can actually do that, not some kind of rewording of a fraction, which is all that percent means. So percent notation right there, if you know that and understand what that's doing, you basically have every bit of information that you need to work with percents. So, and why did they do that? I mean, really you have comparisons of numbers going on all the time. In fact, that's really the definition of a fraction, is a comparison between two numbers. So if I have 4 out of 5, we would say that that is 4/5. And so the 4 is the numerator and the 5 is the denominator. And we'd end up with 80%, which is the same as converting that 4/5 to some number over 100. Well, I take it times 20 over 20, which is I can multiply by 1. That's the process we go through when we're adding fractions with different denominators. So there's nothing really new as far as process. And if you understand the parts of the fraction things, percents become very, very simple. So when we're converting to decimal notation, which is basically fraction notation, decimals like this right here, this 0.01 is a fraction, right? It's 1 over 100. There's two ways to express 1 over 100. 1 as a numerator and 100 as the denominator. Well, decimal notation is just a simple way to write fractions where the denominator is a power of 10. So we have 10 to the 2 power, which is 100, and it ends up to be 2 places to the right of the decimal. There are definitely some patterns and things like that. I don't want to get into that too much. I think that we get so hooked into memorizing techniques a lot of times when it comes to this, about moving decimal places and all that kind of stuff, that I really don't want to talk about that. I think it actually has hurt you and hurt a lot of students as far as understanding fractions, but because you just memorize a technique and not think about what's going on. I kind of left this on. I've had a lot of questions from students of not understanding maybe all the resources that are available. I did another video about resources that are available on this My Math Labs, which is a very nice platform. I mean, you have a lot of different ways to look at this given material. And that's why I tend to focus more on strategy. And we're going to talk about strategies when it comes to percents. And really my strategy mostly amounts to think about what percent means and you're done. So they give us some examples here of some things that I'll go through quickly. I'll kind of just probably not go through all of these, just a couple to illustrate that if you remember what that means, you're done. It's taken care of. It says convert percent notation in the following sentence to a decimal notation. And also it's going to introduce some language again about converting from English to algebra, which is really a language. It says only 20% of teenagers get 8 hours of sleep per night. And so they give us some information. What does that mean? Well, and how could we apply that if we're going to say, well, if this is absolutely true, I have 100 teenagers, what does that mean? How many teenagers are not getting enough or getting enough sleep? And so on. Well, 20% means 20 hundreds. And they say, well, 20% is 20.0%. And I don't know why they would write the decimal in there. Really, they're just trying to introduce a decimal. And then I would divide 20 by 100, or consider this to be the fraction 20 over 100. That replaces the percent, and which is, do that division on your calculator if you forget. If I remember that percent means hundreds, I put the number that they give me that they say is a percent and divide it by 100, and that gives me the decimal notation. And now, possibly, I think after you do that for a while, you're going to see that it really just moves the decimal place 2 places. But again, I even hate bringing that up like they do here, because, oh, you just do this or just do this. Remember when I talk about that, when people are helping you, and do this, because you're going to need to know what this means as far as a lot of different ways to approach this, and then you end up with, now I got 4 or 5 different memorized techniques to deal with percent. Well, when I do that, and then I can say, well, sometimes I divide by 100, sometimes they're showing me multiplication by 100th, or the decimal notation of 1 over 100, and they take 38 times this and do that to reverse this thing, right? And then you go back and back and forth. They're showing us both these examples. Okay. So they give us these examples. I'm going to pick out a couple of the fractional ones, and we tend to say, well, take any fraction and convert it into a decimal. Well, there's some problems with that. If I take a fraction like 1/3, now they don't show us this right away because they're going to show us the techniques for where it does work. Like if I take this 1.27, that really is 127 over 100, which means that it is 127%. And then they say, if I think about what this decimal means as far as fractions, or this is 1 and 27 hundredths, but how would I write this as a fraction and understand what decimal means? Now you've converted. 1/4, they say, well, do the division and basically create the decimal portion for that, and you get 0.25, which is 25%, because 0.25 means 25 hundredths. And then they go through this stuff about multiplying by 100 and writing the percent. I would just say again, if you know what percent means, it means hundreds. If I have 25 hundredths, how many hundredths do I have? 25. So I get 25%. And so on. If I have 3/10, how many hundredths is that? Well, that's 30 hundredths, which is then 30%. Now, keywords they go through here. This is translation stuff. We did a lot of this stuff. These words were given to us in chapter 1, but they're bringing up keywords again because we're going to start solving percent problems. And I said, well, and they don't show us this one. What if I had 1/3? If I had the fraction 1/3, well, if you go and divide 1 divided by 3, you get 0.3 repeating. What percent is that? You got some issues with now, well, it's 33.3%. No, now you've just approximated that. So you have to think about what that means, and when we translate those things. Well, now they bring up keywords. Of means multiplication. Is and was are equal. And what is a question, usually is translate, like percent translates to hundreds. That's all they're saying. So what percent translate into a multiplication of that? Translation means to change from percent to hundredths. How do I do that? I take it times 1 over 100 in this form or fraction form or decimal form, same thing. So what is 11% of 49? Well, I write an equation from this. What is what I'm looking for? I usually say I define the variable first. And in this case, what is 11% of 49? Well, what am I looking for? Well, that's what I don't know. That's my variable. In this case, they say A. And then I would rewrite it. A, or reread this with the variable in for the question, right? So I'd say A is 11% of 49. A equals 11% times 49. Well, I can't multiply by percents, so I have to convert this percent into a number. Well, what does percent mean? It means hundredths, so I'd say A equals 11 hundredths times 49. Done. I do my multiplication after I translate this into a true equation, which is numbers, operations, equals, and variables. I can't have percent. This percent symbol, again, is just a translation to hundredths is all it means. It means hundredths. So if I say 11%, I say 11 hundredths times of 49. Done. Okay? Well, in this case, they say 3 is 16% or 16 hundredths of what? Well, what is my variable? Again, I think about that. So I'd say 3 is 16 hundredths of A, or Y in this case they use. Now my equation is written. 3 equals 16 hundredths times Y. Then you solve this equation. And I see this all the time with students. Once we get to percents, now you're going, we've had all the way through middle school and all these different methods of cross multiplying, all kinds of memorized techniques for all the confusion that comes around this, when it's really of confusion about working with fractions and percents or fractions. If you get past that, it becomes so much simpler. So we get a simple equation of 3 equals 0.16 y. Well, I solve that equation by taking the reciprocal of 16 hundredths. I could say it's really 100 over 16 times both sides and get 18.75. All right, here's another example. What percent of $50 equals 34? Now here's the part where I think you can, here's another strategy you can work with. They show you one is to say, what percent n? They're going to say n, and a lot of times they choose their variable based on n is going to be a percent. They're saying what percent is this variable that is a percent. Of means times 50 equals 34. Well, they get n, then they solve for n, they get 34 50ths, or 68 over 100 would be another way to write this fraction, because then I need to convert this to a percent. So we get 68 hundredths, and then they don't want the answer in a number, they want it in a percent. So what I think is a better strategy is I do just like I did up here. I converted percent to number, right? So even when I don't know what the percent is, I can convert that to a number and write this as n over 100 times 50 equals 34. And guess what? When you solve that, you'll get 68, which means 68%. So in other words, if I convert this percentage statement into a number and say that this is x over 100, that is, some number over 100 means percent. That's what percent means, hundredths. So what unknown amount of hundreds times 50 equals 34, and then solve that equation, it will come out in the form of what your answer should be. I see this error all the time is you set up this equation in this mode and I get this answer for percent. You say 0.68% which is off by a degree of 100 times, right? It's 100 times wrong. So one way to address that is convert the percent into a number again, an actual real number that we can multiply by, and deal with it that way. Because that's what they do here, right? Look at this word problem. I'm not going to read it all, but they need to translate this again. This is just chapter 1 stuff again with this new idea. What is a percent? Well, it's hundreds, and everything's the same. And then you translate to an equation, solve the equation. Now here they do one right here. They say, well, if you do this division, they say it's approximately equal to 0.82. Guess what? They got a repeating decimal. Now, you may need to think about what is really going on with this this example problem, where I don't need to be accurate out, to doing that. But they'll usually tell you in the tests that I give, and even in your homework, it'll say if you need to round something or only represent a certain amount of decimal places, they'll tell you which place to take it to. Because this is a dangerous thing to do, especially if I just started with an equation. Where here I would go, again, I wouldn't write it this way. I'd say this is x over 100 times 139 equals 49, and then you're going to get 82 point some deal. I don't have a calculator out right now to do what that decimal is. But I caught this right here, this little, when they do a squiggly, these little tilde symbols instead of the straight line equal, that means approximately equal to 0.82. So they're saying this division is approximately equal to 0.82 or 82 hundredths. But they drop some stuff off in that approximation. Same thing here, they do an approximation. And that's really all. This is pretty simple. I think as long as you remember and understand how to deal with percents and what that really means, I think you're through this. This is good review of translating to equations from word problems, actually doing applications.